everybody, and welcome to Talking Bollocks, episode 13. Today, we've got a little extra special one for you. Dr. Mike Berry is going to give us a little presentation on coral quarantine and the reasons why you should quarantine. And I will warn you now, some slides are like something from a horror show. Anyway, thank you, everybody, for joining. And I'm just going to say, if you like what you see, you could hit like and maybe hit subscribe. And instead of leaving it until the last minute, when everybody has already given up and stopped watching, we do have a reefing Discord. And if you wish to join it, you will find the link in the description below. Take it away, Mike.
All right. So I put a little talk together this week. It only took like 12 hours to prepare. But anyway, so we're going to talk about quarantine. And just to clarify, we're not experts. I'm not an expert. We're all idiots, and we're just going to stumble through this and see what we can do with this.
Yeah, that's a new slide, Mike. I don't remember signing off on that.
Sorry, Ron. This is how it is.
It's true.
Anyway,
it's true.
So why bother to quarantine in the first place? Because, we all love the idea of biodiversity in our reef tanks, but some of that biodiversity is not going to be your friend. And so when you get something like this, which is Altutholopsis, it's going to wreck your tank. And that's what we're trying to avoid. Because this is like the trough, well, when it was happier than it is currently. And can you imagine getting rid of parasites here? It's a complete nightmare. There's like 32 square feet of coral. Even dipping is an impossibility. I tried it and I basically was exhausted by the time I finished it. So you got to prevent that shit from getting in here. And that's kind of the whole point of this. So we're going to go through the usual suspects. And I love this slide because the reason everybody's laughing is because Del Toro farted right in the middle of it when they were actually shooting it, and they saved that take. So that is absolutely,
it's Zach.
The most appropriate slide for us in terms of the bollocks talking about this. Yes. We're going to start off with small stuff and we're going to go up to bigger things. So microbial stuff, so things you can't see, viruses, bacteria, protozoa. In years past, we knew things were happening, but nobody had a good idea. Since the advent of the aquabiomics, we now actually know that there are specific coral pathogens that we're dealing with. The most common of those two, well, we'll go into in a little bit. So because of that, we have an idea. Now we have nothing to test for viruses, and protozoa are also limited in terms of what we can get out of the aquabiomics testing. So viruses are a big unknown, even amongst the scientific community. We know there are lots of coral viruses. We're unsure what they're doing. They may be associated with some diseases, including SCTLD. There's at least a theory of that at this point in time. But we have no idea to know what they're doing or what to do about it. This is a picture of a bacteriophage lambda that I swiped off of Wikipedia. It's a nice picture though. So bacteria are the things we actually know something about now. So in wild corals, there are quite a few bacterial diseases that are widely known, white syndromes, things that affect octocorals, a variety of other things. We're now starting to see some evidence that some of these actual bacterial diseases affect our aquaria. And Archibacter 1103, or species 1103, is one that they were able to find through the aquabiomics testing. Essentially, a coral that was in the process of dying from RTN, they swabbed and sent off, and it came back massively high in this specific strain of Archibacter. And so since that time, we've been able to associate that Archibacter strain with RTN events, so rapid tissue loss events of corals. And so it is known to be a pathogen at this point in time. Now, SCTLD is stony coral tissue loss disease. It is a disease that developed in Florida in I think 2015. occurred in Key Biscayne in that area, was initially seen with basically a slow progressive loss of tissue amongst LPS type coral. Does not affect the Acropora in the Caribbean, but it's a very difficult disease to pin down. It's associated with at least half a dozen different bacterial strains. It may be associated with a virus that actually makes the corals more susceptible to these bacteria. It's unclear why these bacteria are specifically causative organisms or whether they work together. Regardless, it's a very difficult situation to deal with. It was found to respond to amoxicillin, which is kind of strange because most of the bacteria involved in SCTLD shouldn't respond to amoxicillin. They should respond to other types of antibiotics. So it's still not clear why that's the case or what it's doing. Now, Vibrio is a well-known pathologic bacteria family. A fair number of Vibrio are fine and actually beneficial in reef tanks, but there are quite a few that actually are coral predators or pathogens. The Vibrio coralliticus is one of the well-known ones. This is an electron microscopic picture of one. And essentially, they end up causing an RTN type picture in some corals. Now, that's not been clearly shown in reef aquaria currently, but it probably happens anyway. One interesting thing about
aquabiomics, the aquabiomics identify what strain of Vibrio it is, or is it just general Vibrio?
I think they're usually doing Vibrio families. So just like the genus of Vibrio more than anything else. So I haven't actually seen coralliticus or anything like that specifically within like a coral pathogen. So the question is why? I mean, they do actually see Vibrio like fortis, I believe, which is fish parasites, but I'm not certain as to why we aren't seeing more Vibrio. On the other hand, there have been reports of people who've had very high levels of Vibrio in their tanks that once those were rectified, the corals started growing better. So there probably is a role here, but we're not sure what it is exactly. Another thing to be aware of, dinoflagellates. So Ostreopsis and a variety of other dinoflagellates produce palytoxin. They excrete it, and they can produce very large amounts of it, much more than even like a zoanthid or polythoa could produce. They tend to grow in certain settings exponentially, and amino acids is one of the things that I ran into because these are pictures from my tank. That combined with Ostreopsis ends up with a massive outbreak of Ostreopsis. So this is one of my old, and I was using amino acids. Corals were growing great. I got a frag in from another person, apparently Ostreopsis with it. And within a week, this happened. Basically, the water turned brown. And kind of characteristics here, the corals tend to have this burned sort of look. It looks like somebody like blowtorched off the tissue. And then I noticed also very obvious like changes of the skeleton where it would turn green and then eventually turn white thereafter. So another horrible thing that you want to avoid. Getting larger protozoa are well associated with something called acroporid white syndrome. So that is a disease seen in the Pacific where essentially there is loss on Acropora, but there's no definite causative organism. But every time they've seen it, the Philaster lucinda protozoa is there. So there were some studies done where they tried to kill off the Philaster, and it seemed as though the tissue continued to die. So it probably isn't causative, but it is what's known as pathognomonic. So when it's present, you probably have acroporid white syndrome present in the tank. I don't think it's completely elucidated in terms of how associated the protozoa are with this, but it's something to be aware of. Now, another thing I'm going to include in here, which is not doesn't have a causative organism per se is coral growth anomalies. So these are very well studied in the scientific literature. They're a process of pseudoneoplastic coral growth. It may be infectious. It correlates with the presence of raw sewage. There's one report where there was essentially a buoy sitting out in the ocean over a reef where a bunch of birds would basically poop. And underneath that buoy, there were suddenly growth anomalies that developed. And similar, wherever human sewage is pushed out in the ocean untreated, they see a lot more growth anomalies. So it may be either from nutrient enrichment, or it may be a microbe that the land animals are essentially sending out to the corals. But what you see is this highly disordered growth, often with altered pigmentation. In the wild, it tends to be white in reef tanks. I haven't noticed that as much, but you can see this is an Acropora or Acropora insignis. So normally it has a branching sort of almost pseudo staghorn sort of look to it. It's very pretty coral. This developed from a perfectly normal frag. So you can see like there's a polyp, but all this abnormal tissue is growing out. There's another polyp, more abnormal tissue all over the place. Very atypical, very unusual growth. And in my system, this is infectious. It is definitely spread to other corals. So it's something to be aware of. We have no causative organism. We're unsure what causes it, but it does exist. So getting larger.
Mike, are you shitting in your tank?
I haven't recently, but you have to start a microbiome somehow.
I'm sitting here thinking, do I say that this is Acropora chodensis? And Jim comes out with, have you shat in your tank?
I was so close to texting you, Ron, and asking you the over-under on chode.
Because look, there is an actual chode right at the top. Yep.
Yes, those kind of look like dongs, actually. Anyway, we're moving on. So getting to larger size things, copepods, technically you can see with your eye, although it's fairly difficult. There are likely thousands of species of coral parasitic copepods. I read one paper that was from like Madagascar or someplace like that, where they found 5 new species on one coral. So these things tend to live in the polyp itself or on the coral tissue. Most of them tend to be parasitic or eat the mucus on the corals. In the hobby, red bugs, which are Tagastes acrobranus, have been known for a long time. And most recently, we're learning more about Altutholopsis corallinus, which Ron is especially familiar with.
Yep.
We're going to go through those a little better. So red bugs, they're actually yellow, but they have a prominent red spot on their butt and a prominent red eye spot as well. They don't lay eggs, they're live bearers, which is really nice. There are probably more than one species because white versions of red bugs have been seen, like the one on the right over here, although that could also be an immature version of it that just hasn't developed pigmentation yet. They tend to be easily managed with melbomycin oxime and similar compounds. Essentially, they die fairly easily. They're laterally compressed, which means when you look at them on a slide, they're always lying on their side. You never look top to bottom on these. They tend to present with essentially like polyp retraction. The coral just looks worse and worse over time. And then if you get enough of them, coral death can happen. Most typically Acropora and other similar branching corals. Next, we have Altutholopsis, which is very common and much more occult, very often missed. It's resistant. It can be resistant to a variety of dips. So this is one of the things that can get through your dipping regimen and probably lays eggs as well, which means its eggs will probably get through as even if you kill off the main actual copepod. Sorry, I lost the word for a second. So they present typically with lesions on the corals that tend to be gray in color that enlarge over time. So basically a hole forms and turns gray and gets puffy and enlarges, eventually leading to coral death. And Scott Oliphant did a very excellent talk about his experience with this type of copepod in Australia. They probably end up with secondary bacterial infections, secondary to them chewing on the corals, and that's often seen as well. So RTN events associated with these can occur. Likely multiple species of this exist. So the ones Scotty had were brown striped. I've seen yellow striped. The clear ones may be immature or another species. So they're probably like tens of species of these things. Given that some seem to be extremely resistant to dips, like Scotty's didn't die in potassium chloride and required all sorts of intense treatment to get rid of. These pictures here are all from potassium chloride dips, which they died very easily in. So I probably have a different species than what he had. Regardless, they tend to be very insidious, easily missed, and are much more common in the hobby than people realize. Once I started dipping everything in potassium chloride and doing microscopy of frags that I would get, I found them from numerous vendors. So they probably are in people's systems and they just don't know them. These, in comparison to Gastes, are dorsoventrally compressed. So they're flattened top to bottom. And so they always lay flat on the slide. So they're laying on their essentially belly or back. All right, moving on to other things that are less well known. So halicarod mites. So these are black bugs, at least on the reefing forums. They are literally very small saltwater mites that when you look at them, they look like little black specks moving around because their legs are transparent and they have a black idiosoma in their body that makes them look like little bugs moving around that are black. Most of these are probably detrivores, so feeding on dead tissue or other things of that sort. But they have been correlated with STN, RTN events, particularly of Acropora. The role here is unclear. It's not sure whether they're directly feeding on the coral, or they're feeding on dead tissue, or the thing that I am concerned about is that they are disease carriers that feed on dying tissue. So mite diseases in terrestrial animals are fairly common. So mites often carry some sort of like viral or other similar disease. And so one possibility with these is that they could be carrying something that they introduce into the coral dies, and the mite feeds on the tissue. Now, I found these in my tank when I had an Acropora white syndrome outbreak, which led me to be concerned that they were the cause of it, essentially biting the coral, leading to some infection, and then feeding on the tissue. I never found a lot of these, but I would find a couple of them on the dying corals. So it's something to bear in mind. Now, these things are resistant to most treatments, and people have used insecticides, all sorts of harsh things, and they tend to like be unbothered by it. So they're very scary. Yes, some little videos. They're very creepy to watch. All right, so then we move up to macroscopic coral predators and parasites. So there are a variety of things. Acropora eating flatworms, Euphyllia eating flatworms, Caribbean bearded fireworms, corallivorous sea spiders, of which there are at least two varieties, the ones that go after zoanthids and ones that are non-specific and will eat everything in your tank. Sundial snails, which go after zoanthids, Drapella snails, which go after stony corals, gorilla crabs, which eat whatever they want, corallivorous amphipods, which are something like I believe the Long Island aquariums have been dealing with, where essentially an amphipod just like strips a coral overnight. Very scary. And then, of course, nudibranchs like Montipora eating nudibranchs and other things. There are a variety of those. Basically, there will be a nudibranch that eats any sort of coral if you're unlucky enough to run across it. So all these guys are, of course, things we want to avoid if humanly possible. And then on top of that, we have things that are not going to necessarily just gank your coral right off the bat, but are just going to irritate it or irritate you. So vermitids, acyl flatworms, hydroids, algae, pest anemones, coral boring spionid worms, things of that sort. They're going to be a pain in your butt, and it would be nice to not have to deal with this. When you have, the vermitids eating into power cords, as was the case here, Exaptasia, and then this is bryopsis in my tank currently, which is currently dying because I treat it for that. All right, so now that we have a rough idea of what the players are here, we need to think about what we're going to do about it. So, the approaches can be just doing nothing, watchful waiting essentially. So you're just going to throw the coral in your tank and hope for the best. And choosing only healthy corals from known vendors. I've tried that. That doesn't tend to work out very well because known vendors tend to have still problems that they're not aware of, like the Altuthalopsis. I have found from known vendors that had quote unquote healthy corals, but didn't realize they had that parasite in their tank. So dipping only is something a lot of people do. So you dip the coral when you get it and then plug it in your tank. I think that's a reasonable approach, but you're going to still be in the 90. Okay, can you hear me now?
Yep.
Hello?
Yes.
Yes.
Okay.
Yes.
All right, so we're going to start again. Approaches to coral quarantine, I think, is where, and so basically let's go through none. So basically watchful waiting, hoping that things are going to be fine, choosing only healthy corals from known vendors, which we'll talk about in a second. Dipping as your only treatment, which probably gets you to 90% chance of getting rid of most parasites and other things. Dip plus base removal, so removing the frag plug and any like exposed skeleton, and then dip plus quarantine. And then dip plus multi-stage quarantine is the final option, which is probably OCD for everybody here. So watchful waiting. So you have zero protection from disease. You basically are just hoping that everything's going to be good, and you're going to run significant risk with doing this. Trusted vendors can still have parasites and bacterial problems. Copepod parasites can be extremely difficult to see. If you come in with, a couple of copepods on one frag, the frag is probably not going to show any problems at first, but once those copepods start to reproduce and you start building a large number, then things are going to start looking bad. You're not going to have an idea what's going on. And by that point in time, it's probably spread all over your tank and you're probably going to have issues. The only benefit I can think of just doing nothing is that you may limit your microbiome shock. So we know, especially from purchasing corals that come from the wild through a variety of scientific studies, corals, when they move into captivity, have a major change in their microbiome, such that part of the microbiome dies off, and a lot of the bacteria species shift in terms of their presence on the surface of the coral. And when that happens, that's probably one of the major reasons things don't adapt to captivity, is because essentially they've had a big change in their microbiome. There is some literature out there where they have compared corals that they brought from the wild into captivity and antibiotics versus ones they haven't. The ones they did treat with antibiotics show improved survival in captivity, but that's not something we all should be doing. It's probably better just to buy aquaculture corals which have already adapted, rather than trying to adapt wild corals by antibiotic treatments. So dips. So this is like, basically I'm just going to start trying to prevent problems, and this is the kind of the basic way of doing that. So there are a ton of dips out on the market nowadays, and I've listed these here. So the essential oil dips, which are like Melifix, Coral RX, use Melaleuca, which I believe is from tea tree oil. And then you can have a variety of other ones. Clove oil and a variety of other essential oils can be used for dips. And I've tried several of them. They're surprisingly effective, and they will kill quite a lot of stuff. They're generally safe to dispose of, but they can have side effects such as brownout, which is something people see, where essentially the coral just turns brown and kind of sits there for months afterwards. It's probably related to the fact that these oils are going to penetrate into the coral itself and cause problems there. They may be effective against some protozoa, especially clove oil, and possibly against the halicurid mites, because there's some data on that. Not so much the marine mites, but actually terrestrial mites in essential oils. So moving up, we have Bayer, which is imidacloprid. So it's basically an insecticide that people use as a dip. It's very effective at killing things, but it's also very toxic. And disposal in this instance gets to be an issue. So if you use Bayer, you should bleach the water. So pour straight chlorine bleach in the water, let it sit there for a week or so until you get this white precipitate. At that point in time, it's safer to dispose of, but not necessarily safe. So that's something you're going to have to make a choice on dealing with. Potassium chloride, which is usually, or potassium chloride / sulfate, reef primer, potassium P, potassium chloride off of Amazon, et cetera, et cetera. So it has a very wide spectrum of efficacy against a lot of things, copepods, flatworms, a variety of other things of that sort, when used at the high concentration of 10 grams per liter for 5 to 10 minutes. I saw a report recently where somebody was doing like 8-hour dips, which is an interesting approach to it as well. It's completely safe to dispose of. You will not cause any problems by pouring it down your sink. Issue with it, some copepods and other organisms may survive even high concentrations. Altutholopsis, when Scotty was trying to kill it, did not respond to potassium chloride at all. And halicurid mites, the ones I show in the slides, basically I was able to isolate with potassium chloride, but it did not kill them. And that's one thing I'm going to add in here before I forget about it. There was actually a paper written on dipping corals where they figured out that essentially if at the end of the dip you shook the coral in the dip solution aggressively, then it was much more effective than if you let it just sit there, because the stunned organisms don't get knocked off. So essentially at the end of your dip time, take some like tongs or your fingers or whatever and like vigorously shake the coral back and forth in the water, and that will end up with much more effective dips no matter what you're using. I would not do that with Bayer without gloves, or some of the other ones I'm about to get into. So iodine-based dips, Seachem reef dip, Lugol's, etc. These are kind of very old school dips. They can be effective against some creatures. I don't tend to think they have the same efficacy as like Bayer or potassium chloride, but they may be beneficial against bacterial diseases due to the iodine content. So that's something to bear in mind. LPS seem to tolerate a little better than SPS, but it's variable depending on the concentration you use. When using these, they're like, add it until the water looks brown. That's not quite as specific as like potassium chloride, where you need a scale to measure it out and get very precise concentrations. Milbemycin based, the Dr. G's dip that is available in the US, theoretically it was milbemycin based, although it may no longer be because I think there were some issues with the FDA. It was historically had efficacy against copepods, but may or may not affect Altutholopsis, which again can be resistant. Ivermectin is another very strong dip. So this is usually a livestock solution, 1% livestock solution. A variety of vendors and sell it, and you can get it from like Tractor Supply and things like that. It's extremely effective versus copepods and large coral parasites and very, very toxic to everything else. So if you pour this down your sink, you're going to kill off anything in the groundwater. If you pour it in the ground, you'll kill earthworms and all sorts of other organisms. It lasts for years in water and soil. So it's very difficult to get rid of. I use this dip, and when I use it, I put basically half a bottle of chlorine, sit there for a week or two until you get a white precipitate that falls out, which is the compound coming out of the water. At that point in time, I feel much safer about getting rid of it. But it is something you have to be very aware of. The imidacloprid is toxic, but tends to get broken down a lot faster in nature. Ivermectin does not. It sticks around for a very long time. Moving on, hydrogen peroxide used most of the time to treat algae, but can have some efficacy against other organisms. It's not very well studied in that regard, but people use it for a dip occasionally. And one thing to note, antibiotics are not dips. They should not be used for dips. They take oftentimes at least 8 hours and often 5 to 7 days to have a true treatment effect. So this is not a dip. People using them in their, coral dips at this point in time are running risk of causing resistance and or just wasting the antibiotics down the drain. Any questions? Can people hear me?
Yeah, we can hear you. Well, I can.
Okay, good. All right, so one of the things that's crucial here is having some way to figure out what's there. So microscopy is really important. It seems weird that you need a microscope to have a coral tank, but it's so beneficial to have one, especially when you're dipping corals. So many of the parasites things are too see with your eye. And so with that, it helps us to identify what we've got. When people come to me with problems with their corals, I often say, have you done an aquabiomics? If that's negative, have you dipped and done microscopy? Because that's going to usually answer a lot of the questions. So for microscopes, you have compound, you have digital, and you have dissecting, which I put them in the wrong order here, unfortunately. So that's a dissecting scope, digital and compound. So I have a compound that I use. I also have a dissecting I never use. Ron has the digital on the right. And essentially, the compound will get you to a smaller size organism than you can see with the digital or the dissecting. Dissecting is usually for fairly large things. So if you need to look for osteopsis or a dinoflagellate, compound's going to be the one you want to use for that. If something like copepods, you may be able to see them effectively with a digital microscope, and that's something worth having for that because you can get really nice pictures and video of that. The dissecting scope is really for looking for larger things because you're going to be much lower power in general. Having more than one would be really nice. Having a digital and a compound would be nice, but it's a lot of money. So base removal. So exposed coral skeleton is where typically things lay their eggs or hide. That's where your parasites, predators, and other things tend to be on wild corals and in things from aquaculture and mariculture. So mariculture bases are fairly notorious for both harboring parasites and potentially for releasing toxic compounds into tank water. People have found like chunks of iron in them and other things. And so removal of the base from a mariculture coral is usually a good idea. So once you remove it, you can put it on a frag plug or something else that you know is clean, and thus hopefully get rid of one potential site for parasites and other things to get into the tank, as well as chemical compounds. When you get a frag on a frag plug, again, you can have a lot of things hidden on them. I found things crawling underneath frag plugs before, which probably were halocarid mites and other things of that sort. There are two approaches: either remove the frag plug or the frag from the plug if possible, or the other option would be to just super glue over every surface of the frag plug. And that should basically prevent anything that's not bacterial from getting into the tank. So if we have exposed skeleton, again, trimming off the exposed skeleton is probably a good idea to prevent eggs and other things from getting in the tank. So the quarantine tank itself is just another reef tank. Unfortunately, that's basically what you need to run it at, but functioning more like a frag system. So with trays and things like that, no sand bed. You want it so you can turn it over easily, so you can sterilize it if you have things come through that obviously have disease on them. You want to be able to wash that tank out and make sure there's nothing still living in it. UV may be beneficial when we're doing this, and that is debatable because there are not that many diseases that are sensitive to UV for these sort of things, but some people push it. One option for setting this tank up also is to use it as a biological control tank. So a paper was written where they used 6-line wrasses and peppermint shrimp to get rid of acropora eating flatworms, which were brought in on wild colonies. And they're surprisingly effective within like 8 to 12 hours. So essentially the peppermint shrimp eggs, the 6 lines ate the adult flatworms, and they were very effective at getting rid of those. Now you might want to have a tank where you just have 6 lines or peppermint shrimp in there, and then move them into a second quarantine afterwards. So you don't have to like worry about maintaining, shrimp and wrasse in your quarantine system if you have to clean it out. Another idea would be to put Bergia in there to get rid of excess, or something along those lines. So the actual process, I've reviewed what I could find on this. There's not a lot out there. Like Kevin Erickson has a video, and a couple of other vendors have videos on this and a couple of sites. But essentially, the idea is you get the coral, you look at it, you see if there's something wrong with it. You look for macroscopic parasites, remove those. You remove the base and any exposed skeleton. We're going to dip corals with whatever dip you want, and that can be one or more. Like I tend to do potassium chloride followed by ivermectin for a variety of reasons. And then we go into quarantine. So 30 to 60 days was something that I saw, but that's not going to get everything. So like the coral growth anomalies that I have in my system that came in on a frag, I would not have picked that up. And that's something to be aware of. Now, that's something you may be able to tell right off the bat when you look at the coral that you buy, but it's something that will show up later otherwise. So during quarantine, weekly dips is something that I saw recommended as like an option. And the reason behind this is things may survive your initial dip. And so either it survives or they lay eggs that hatch later on. And so if you dip every week or so, do microscopy, you can keep an eye on things and see whether anything has come back or, is not responding to the treatments you've done so far. And then, of course, during the 30 to 60 days, you can deal with pests, anemones, algae, et cetera, which gives you a chance of keeping those out of your tank. And at the end of your trial period, then either add it to the tank or move it to a second quarantine grow-out system. So that's something that I saw recommended, where essentially they would take the coral and put it in a grow-out system to allow it to mature and make sure, again, that we don't have term problems with the frag, and then finally move it to a display system afterwards. And that's it. And part of the reason I'm using this slide, these corals have a growth anomaly that I picked up from an online vendor. You can see the polyps aren't shaped correctly. They're very odd looking. Growth is atypical. This, as far as I can tell, is a Crocodida, which is a branching coral, not a plating coral. But it grows this way because it's picked up this growth anomaly. This is the thing that brought it in. So this coral essentially is the one I purchased from a vendor. I thought it, quote unquote, looked cool, which was my mistake because I didn't know what I was doing at the time. And unfortunately, it brought in this abnormal growth pattern. And so I have stunted branches that don't grow normally, abnormal tissue, the skeleton grows abnormally. It's some sort of like growth anomaly or other thing. I've looked into a variety of things, including possibility that could be trematode related, but I still don't have a clear answer as to what's going on. And unfortunately, because it's spread all throughout my tank, affected essentially all a cropper in there, I'm going to have to shut the tank down and restart from scratch. So, all right, that's my little presentation.
Thank you so much, Mike. That was absolutely incredible, and I'm sure everybody has got something from it. Just on the subject of that absolutely bonkers-looking coral there, so you bought that because it looked different, but now you reckon whatever that coral has, and we don't know what it is now spread through your entire system.
Correct.
That's terrifying.
Yeah, it's really unfortunate. Like even in the picture behind me, on my like screen here, you can see the green corals growing there are actually tenuous, which are foreign-bows type corals. So they grow as like, kind of a pillow shape with little branches everywhere. These grow as long branching staghorns in this system. And that's another version of this. Either I get stunted branches or I get branches that are way too long. And it's clearly something is affecting growth that is infectious in this tank. Regardless, I'm going to have to start over and just trash everything, unfortunately.
That is not an easy decision.
That sucks.
Mike, I got a question. So when we think of like fish disease, we think of a lot of times as fallow periods. Is some of these pests are coral specific? Do we know if some of these parasitic copepods will die off without having that coral that they like to live on being present in a tank, or will they just live on something else till the time comes? Do we know any of this? Like, can we do a fallow period or?
I think for Tagastes, that has been shown, but in like a month or two of fallow period with no cropper in the tank, that those will tend to die. I do not know for all Toothalopsis. It is way tougher than Tagastes. So the black, whatever color bug you want to call them versus red bug, they're essentially much hardier. I would not want to partner with them.
So I still have to do a little test with. Obviously, we are not legally allowed to source bear here in the UK because of the active ingredient, but we do have an ulterior alternative product called acetamiprid, and I still have to do a test on that. I'm actually specifically growing a batch of Acropora purple valida for this very reason, because they were the most susceptible to the copepods I had, and I'm going to do some dips in this acetamiprid that we have here in the UK, which is actually for vine weevil treatment. So I'm going to be interested to see how that goes. But like I say, I'm actually growing a specific batch of corals for it at the moment. So and I'll update you all on that tasty morsel.
And do you have the copepods to give?
Not at the moment. No, that's the problem. But I'm going to see if it kills. So putting these corals in KCl killed everything except these parasitic copepods I had. They didn't even sniff at it. Nothing did. Unbelievable. But every single other organism in the coral, from what I could see under the microscope, got completely wiped out with the KCl. So I am going to start testing with this acetamiprid to see if it does anything to begin with. But yeah, I am now out of the bad boys, so I might have to try and source some. But I'm pretty sure I got them from maricultured corals from Indonesia from a company called Golden Marindo. I can't think of anywhere else I would get them here. So that's what my money's on.
So when we're quarantining coral and we have a separate trough that we're observing the coral in, we're not really treating coral in the observation tank. We're just using it as a holding cell to pull the corals out and do dips. But is there no concern that whatever pests are on a specific coral can live on the frag tray or you know what I mean? Like if you're just pulling out corals and dipping, is that going to protect you if pests can be within the system?
Well, for me, I dipped every single coral, removed every single rack, replaced every single rack, cleaned the entire tank top to bottom, but I didn't remove all the water. So, I mean, obviously there's still a chance. There's all my biological filtration and my sump and things that I could have been riddled with it, which is why I went down the milbemycin oxime route with the praziquantel for the in-tank treatment. I didn't have any other option. There was no way to, unless I did what Mike did and yeeted it out into the bushes and started from scratch. And no way. I think I would shut it down and then that would be it. So, Mike, you are planning on binning everything.
Yeah, unfortunately. I mean, as far as I can tell, everything is affected by it. So, and I've looked through the particular vendor that I got it from site. It seems like they're still selling the same stuff that's all affected. So I think the key thing is to avoid that. There are probably other vendors that are affected that are less obvious about it, but we can do a talk specifically on what I found with this at some point in time and just kind of go through all the details of what this growth in is. I don't know what causes it, but I can pick up what it looks like from seeing it so many times. So, or for essentially seeing what happens with it. But
So this
in
vendor,
terms of,
they have more than one coral on their site that looks like it has the same disease. It's not just one they have.
I think it's all throughout their tanks.
Oof.
Yeah.
Oh,
Anyway, which is why I will not give away any corals from this tank, and they're all going in the bushes because I don't want to spread it from my system. The veritable bushes.
So it's a growth form, but like there's no, like you're still researching it. There's no direct evidence that there's a pathogen or a disease at this point.
Well, it spreads, and so that's my basis for believing it's an infectious process. And it's spread in 3 different systems, and based on one frag from the specific vendor, and spread to multiple corals and throughout the tank. At this point, I can't identify any corals that are not affected by it, if that says anything. It wasn't specific to this tank. It's likely to be any sort of like environmental thing in this situation. It's clearly infectious, and that it's spread multiple times in different systems. So I think the likelihood is this is a disease.
And if you were not trying to spawn and you believe this may be causing issues with spawning, would you care if it was just a display?
Hard to say. They just don't look happy. None of the corals do, and they grow in such bizarre ways. Like one coral I had grew like 1,000 little tiny branchlets, so it looked like a porcupine. That's not healthy. And then I see like this mal-shaped skeletons and abnormal appearances. Just the whole thing is just unhealthy looking. I don't think I could tolerate it. I think somebody who didn't pay as close attention as I do probably would be a lot less bothered by it, but I can't live with that.
So I don't like to use the term new because what is new, but how new is this in the hobby? I mean, I didn't know anything about parasitic copepods until I met you fuckers. And if I hadn't bought the microscope, I would never have known, and I would have just gone about my business and just thought, these corals they're not quite the colour they should be, but hey ho. I wonder how common all of this is out there now. I mean, it's a little bit scary now. I wish I didn't know.
I think these things have been around for a while, like including the thing that's affecting my tank. I have traced it back for at least 10 years, if not longer, seeing pictures of old corals that have had it. But things like the copepod parasites have probably been there the whole time. But the difference now is that we have all these online vendors. So it used to be 20 years ago, you would get corals shipped in from Australia, and then you would put them in your tank, right? So they would go to your local fish store or something like that. And so if you got one of these copepod things, they'd wipe out your tank, everything would die, and that would suck. But in general, unless you fragged it and gave it to somebody else, just you who's affected. Now, those same corals are going to vendors who put them in their system and grow out the coral, spreading disease amongst their tanks, and then sell the corals from there. So now we have a distribution system for disease, essentially, which is why vendors have to quarantine. And some do. Like, I've talked to Adam from Battle Corals, and he is very into quarantining and aggressively like prevents any disease getting in the system. But I'm willing to bet that's not true for everybody. And so I think the difference nowadays is essentially is that distribution system now can spread disease effectively.
That makes
It's like COVID in an airport.
Yeah. Not good.
Yeah.
So does anyone want to talk about does anybody here quarantine their corals first and foremost? No?
Nope.
Patrick does?
Yeah, I haven't added anything in a while, and I always ended up losing a lot of them, but yeah, I do.
And do you reckon you lose them because of the quarantine procedure?
I guess it depends how well I'm maintaining the quarantine tank. So my quarantine tank is a 20-gallon long. It's more just a separate tank than a quarantine tank. It's got live rock in it. It's all this stuff. And the corals spend a while in there, at least weeks, maybe a few months. If they need to be medicated, I take them out and put them somewhere else. Medicate them and then put them back. But yeah, I mean, I think overall, if I'm maintaining the tank well, it works pretty well. But if I don't, like the last order I got, I lost a whole bunch of them, and I haven't really got any more since then.
And Rob, obviously, you've just quarantined, you've just cleaned some corals from a filthy vendor.
Yes, absolutely. Yeah, I wouldn't say I quarantine. I guess I quarantine my corals just basically in an observation tank. So I didn't actually, obviously I dipped the corals, but I didn't do anything else. But I kept them in a fish list system. But I was quarantining against fish diseases more than coral diseases. So other than kind of dipping, and I've got I've got a compound and a dissecting scope. So I do look at the frags just to check there's no obvious eggs or anything. I use potassium chloride, and that's about my protocol, really.
Yeah, there should have been almost nothing living on the corals I sent you after the shit they've been through.
I mean, even living coral tissue on some of them.
Well, lucky for me, I can edit that out. Yeah, that Acropora Bill Murray can be a little bit sensitive.
Yeah, just that went instantly.
It was the first one that died in this system when shit went sideways. Just both overnight, white, gone.
Yeah, but 15 are good. I think losing 2 out of 17 is not too horrendous.
I'll replace them. Not a problem. I've got plenty more.
Yeah, that's not what I'm getting at. I'm just saying.
No, whether you like it or not, you're getting more.
Yeah, so Mike, when you were talking about Arcobacter and Vibrio, is there I've got something in my head that says that on the biome of the coral, they can potentially switch from being good for the coral to being almost or causing RTN or STN. So have you heard of that kind of, there's a switching mechanism at some point where they can change from being the good guys to the bad guys?
A lot of this I hear from Salem, and there apparently there are quite a few bacteria that do that essentially have little internal switches, or they have other bacteria that keep them in check, that when there's a biome's change or change in the environment or change in nutrients, they go from being just, commensal to pathologic. So I think Vibrio has a lot of that. Like Coriolyticus is known to do that at like 81 degrees, I think. So when the temperature gets above 81, they go from being a commensal to a pathologic bacteria.
This Robin, Ron, are you guys following?
Was it 81 million degrees? I don't know, what's that? 81.
81 million.
We'll do it in Kelvin next time. But regardless, there's like a temperature cue for this particular bacteria to go from being benign to not benign anymore. and established, and they're Archibacter may be the same, but when it's present, there does seem to be an increased coral death, at least in my experience. And so that one may just be
81 sounds
on its own.
low temperature wise. I mean,
What?
do you run your spawning system? Does it get to 81 or not?
Well, it got to 84 yesterday, but that's a whole different situation. It's during the summer, I usually go to 85, except when the air conditioner breaks. But I haven't noticed any temperature related outbreaks, but on the other hand, the way my system is set up, it slowly ramps up to that temperature, then slowly ramps down, more like that environment. And so I think it's temperature shock that can lead to some of these abrupt changes in pathogenicity rather than like the slow changes over time, because the slow changes allow the microbiome to change with it. But if you suddenly have a temperature shock, then you have like the potential for things going sideways.
So does anybody else quarantine their coral? No. Just not a thing for most. I mean, after watching this, they fucking will.
And I've always, I do dip a lot of things for the most part. It depends on where it's coming from and the type of coral. And usually, if it's a more shady place, that might go into a secondary tank for a bit, or remove a base. I'll oftentimes get out the stereo microscope and I'll visually just give a once over to everybody and have a dental pick handy to see if I see things like eggs, which notoriously in a lot of dips will not die because they're well protected. So sometimes I might do a little manual removal, or if I'm going, that doesn't look right, it might go into a secondary tank for a while. So I've been using a lot of reef primer lately.
Did you say you buy corals from shady places?
I could, yeah. There are some places that you look at and you go, never seen these people before. Might have some interesting corals, but that it's like, kind of knowing who you're buying from sometimes. Or understanding their import practices, because, as you kind of get around the hobby and vendors and learn practices, like I'll throw a good example out there of like, there used to be a lot, and I haven't seen them lately, but I haven't been to a show, a bigger show. But, you get those massive zoa colonies with like 10 different types of zoas on a rock. And it's like, yeah, someone directly imported that, just tossed it in a tank, maybe not dipped it. And there could, I've talked to a few good friends in the industry. They're like, yeah, don't touch those things with a 10-foot pole. They're usually crawling. So, but yeah, generally for me, it's just dips, maybe pulling bases, and on a rare occasion, I'll move it. But I do think having good control in the tank is really important too. Wrasses, pipefish, mandarins, damsels, they all actively will pick at that stuff.
I know 6-line wrasses can be complete dicks, but I've got one in every single tank I have, and they do an amazing job. Non-stop. All up the stems of the frags, right in around the edges. Absolutely brilliant fish. So does anybody have any questions for Mike to really put him on the spot?
I'd provide one additional comment on the odd growth form too. It's an interesting observation of potential disease, but I guess I would kind of flip the idea around too of, is that an adaptation that is spreading through corals to being in artificial tanks? because coral pattern growth will vary based on lighting and flow in the wild. Could that also be the case in the aquarium?
I think that's an interesting question. And some of that you could stretch to be that way. I mean, I honestly think this is a disease, but the picture I showed of the Acropora or Acropora horta that is now growing as a plating coral as opposed to a branching staghorn like it's supposed to, there are examples of similar changes in that species that are for sale and have been for years, where this coral was brought into captivity and it changed to that setting or changed to that growth pattern, and it's basically stabilized there. Whether that's really an adaptation in a coral that's supposed to grow as a branching coral, or whether it's just it basically kind of set up shop with whatever this disease is and is okay with it, is hard to say. I don't know. But if it spreads as this does, it's unlikely to be, in my feeling, an adaptation. I think it's much more likely the disordered growth, the abnormal appearance, the growth types. It's most likely going to be disease. And what type it is, I'm not sure. It could be viral, since it seems to affect growth aggressively. And like I said, I wondered about coral trematodes because that is known for some things like parietes trematodiasis. It's really hard to say. Actually causes abnormal growth. It's the site of infection. There you get these weird little pink bumps all over the coral, but they actually tend to grow differently. And then when you look at actual coral growth anomalies in the wild, they get these bizarre tumor-like growths that are just very disordered and abnormal. That picture that I showed earlier, that looks very much like that. And my feeling, I think it's most likely some sort of infectious process, whether it's viral or multicellular, I don't know. If it were just one coral in my system, I wouldn't worry about it. But since it's spread insidiously to every single coral in there, it's clearly a problem.
And you said you've seen pictures from the wild with the same growth anomaly?
So growth anomalies in the wild, pale white, and they grow as blobs on corals, very abnormal appearing. I thought about putting some pictures. So those are common in certain locations, like I said, places where they have like sewage dumps and things like that. They're seeing much higher likelihood. There are a variety of papers out there in coral growth anomalies, but these exist. The one I'm seeing isn't exactly like that. It's definitely a growth anomaly, but it's not like the typical ones you see in the wild. They're not like bleached looking. Now, I will say some of them do look like that, like the picture I showed of that one coral that had just very bizarre growth. The insignis, for whatever reason in my tank, were severely affected by this, to the point where they all just wiped. They all died. But other things don't tend to show the same sort of response. So I'm not sure what it is exactly or what causes it.
Have you done cross sections of coral skeleton at all? Horizontal or laterally on ones that are affected versus not seeming to be affected? Just it sounds like it'd be an interesting thing to see if the internal skeleton structure is different.
I have not, so I don't really have the equipment. So to do that sort of thing, typically what you have to do is decalcify the coral, and then make slides, like stained slides of them, to really look at the internal architecture. The skeletons themselves, when they die, I can look at very clearly, and they are definitely malformed. So it is the skeleton itself is affected with this. So it's not just the tissue.
Oh, it's very interesting. Thank you for sharing.
Yeah.
So, Mike,
All right, just for the record, or no, go on.
I was just going to ask, if you had to pick one sort of dip regimen to rule them all, what would you pick? It sounds like, regardless of disposal troubles or issues, it sounds like potassium chloride and ivermectin, if you paired those two, are the most effective. What would you say? What would you do if you wanted to basically try to catch everything you could?
That's what I use, potassium chloride followed by ivermectin, because both tend to be fairly gentle on the corals. Bayer is also very effective. Essentially, ivermectin and Bayer are very related in terms of what they do and their actual like chemical compound. It's just that one lasts for years and one doesn't last quite as long in the wild. So I think both those options are good. I am very pro disposal with these things. You have to make sure that you're not just pouring insecticide down the drain if you're going through this stuff on a regular basis. It's nasty stuff, and I don't like it in the waterway. But beyond that, those are the ones I would use, which I consider kind of the modern dips, potassium chloride and the ivermectin, imidacloprid sort of dips tend to be the most bang for the buck. Just KCl itself is really good for a lot of things, but some copepods may get through it. It's the problem with it. Most of the copepods will die with the other two. I would say pretty much all of them will. The issue with the Altutholopsis is they're probably egg layers. And so, although it's not 100%, there's probably a good chance they are laying eggs, which is why they survive the dips. Is essentially they've laid eggs someplace you can't find. They're too small to see. And so that's where cereal dips are going to come in, is to wipe those out. The other option, of course, is mildomycin and just taking them out that way. But again, you have to repeat that to get rid of it. With Tagastes, they are live bearers. So if you kill one, you've killed them all, essentially. So with those, it's one treatment is typically very effective to get rid of them.
Now, are there any of these that can actually hide in the coral polyp, sealed off, so that even if you do a dip, they don't?
Yeah. So that's a good question. So like I said before, there are likely thousands of coral copepods that some of which do hide inside the polyp, crawl in and out of it for whatever reason the polyp tolerates it. The trematodes I was talking about for like Porites do that exact thing, and live basically in the like gastrovascular cavity of the polyps, the inside, the belly of the polyp. That's going to be a difficult situation. That's where a 5 to 10 minute dip is not going to solve that problem. One of the reasons I like ivermectin is it is an hour and a half dip. And so there's plenty of time for that stuff to get into the gastrovascular cavity of the polyp and potentially kill those things off. So is not an easy dip to use for a very good reason, in that it tends to stay on things. So when you dip your corals, even if you rinse them off, they tend to leak ivermectin into the water supply afterwards. Even the tiniest amount of ivermectin will wipe out all of your crabs, shrimp, and snails. So I ran into this when I first tried using it based on like information off the internet. Essentially treated with ivermectin, got a nice dip, killed off all sorts of things, rinsed the corals and put them back in the tank. And the next morning, all of my snails were dead, all of my crabs were dead, all of my shrimp were dead. Everything died just from the little bit of residue there. So when I actually do ivermectin, I do my hour and a half dip, I rinse off aggressively. Then I put them in an entirely separate aquarium in which they sit for 24 hours with a ton of activated carbon to essentially absorb all the ivermectin I can out of the water. Then I put it back into the system. Even with that, I will see some snails that look stunned like in the week afterwards. So it is really, really, really toxic stuff.
How did your ivermectin come in America? I couldn't find any in the UK out with palatable pastes for sheep and horses to find tasty enough to be able to actually ingest. Is it tablets or is it a liquid you guys get?
1% liquid. It's for farm animals. So you can get it from like the farm animal supply, Tractor Supply here, is which typically sells it. But yeah, it is basically for farm animals.
The sheep farms should have them by you, Ron.
Only in palatable pastes which have flavors in them.
Yeah, ivermectin is not something to use without a lot of reading ahead of time because it is very dangerous stuff. It's an excellent dip, but you have to take many precautions with it. And bear probably is a lot easier because apparently it breaks down fairly quickly.
Oh,
it's a imidacloprid and another thing.
Oh, you're
it's
back.
Like beta-cyfluorine. Am I muted again?
No, you're fine. You're fine. You just it all disappeared for a few seconds.
Okay. So the problem with bear is it's not just imidacloprid, it's also like beta-cyfluorine or something like that. The imidacloprid breaks down when you bleach it. The other stuff may not. And so you're again pouring insecticide in the drain when you get rid of that stuff. I don't like that. But between bear and ivermectin, bear is much safer in general to use in a tank because it will break down much faster.
Can you source bear in the UK?
Nope. Nope. Can't get fuck all here. A random guy literally turned up on Amazon for like 3 hours who had it. And I was like, why now? It turned up. I'm thinking to myself, well, I can't really get it anywhere else. I'm going to try again. Gone. Disappeared. You probably shouldn't have been selling in the UK to begin with, but I did manage to get some and it worked amazingly well. Really, really good. So it's a bit of a shame we don't. I'm gonna try this acetamiprid and see if it has even slightly similar results.
It will. You just have to figure out what the dose is so you don't kill your corals.
Yeah, that's the problem. Hence growing some corals that I can just eat.
Ivermectin used in well.
Say again, sorry, Rob. You're very quiet again.
Keep leaning back and relaxing. Isn't ivermectin used in? It's used for onchocerciasis and lymphatic filariasis in humans. So maybe if you dragged a swollen leg down to your doctor, you may get him to prescribe you something which has got ivermectin in it.
Trip to Africa, Ron.
Yes,
yeah,
but
why not?
I mean, I looked to try and get ivermectin. It's just the only thing I found that contained it in very low dose was a spray for pigeons.
Yes, yes. Yeah. I ordered it on Amazon.
Oh, you ordered some?
I ordered some on Amazon. Yeah. And then I ordered it, paid for it, and Scotty said, "Don't put that in your tank." So, yeah.
Yeah.
I think you asked me too, and I was like,
Yeah, I looked at it.
A lot of people have pet pigeons in the UK. Is that like a thing?
Mike Tyson?
Yeah.
Now, Keith. Yeah, it's that's another thing I found ivermectin in the UK was pigeon stuff, and you can just buy it straight off of Amazon, and it's not expensive.
Is that how you guys send notes from England to Scotland still?
Yeah. It's still quicker than Royal Mail.
Still quicker than waiting for a response from Rob on WhatsApp.
The 37th question, how are the corals looking?
Yeah, exactly, yeah. I've got him under bleached Ron.
Bleached. Note to self, edit that out. There we go. Another edit. Excellent. So does anybody else have any other questions for Mike on the subject of coral quarantine?
Well, thanks for putting this together.
Yeah,
it was good.
Thanks for sharing.
It's been absolutely brilliant. So I think we'll wrap it up, and if anyone wants to hang about and chat, and then I don't have to edit all the bullshit out at the end. I'm just being lazy.
All right.
Not as
all right,
fun.
Jason.
Thank you so much, Mike, for your time and your presentation. Absolutely amazing. I know I've learned a lot from it, and I am definitely going to set up a coral quarantine system. So thank you to everybody for taking part. Thank you very much. See you later.
Bye.
All right. Well, if that's the case, and we're gonna edit this out, I'm gonna go take a piss for a minute, and I'll be back in a second.
Oh, no, you're supposed to
Acorn,
say
acorn,
Acorn.
acorn.
A corn. A corn.
Just for you, Jason. Just for you.
I love it.
Oh my god.
This is not getting edited out. I love that everyone gives me about a 3 or 4 minute heads up of sound they want on these talking bollocks, and I've got to scour the internet to find it, then put it onto my soundboard and make sure it works.
Well, I didn't think about the fact that you've probably never seen Jeopardy.
The only reason I have heard of Jeopardy is from White Men Can't Jump. Words that start with the letter Q.
Ah, yeah. Yeah.
What is a quiche?
Kumquat.
Shall we ask Dr. Mike if he washed his hands?
I did, in fact.
What dip did you use?
What?
So I'm not going to edit this out, just so you know.
I hope not.
It's been far too funny.
All right.
Okay, I'm going to shut up now and let you take the wheel.